Okay, hello everyone. Maybe you can. Okay, so we can go through your update. So uh, just let me. Okay, so who start first? Maybe. So maybe you can start from Kong Mei. Are you okay? Or
Hi, Professor.
Kong Mei? Okay, you have a two. Sorry, two. So Kong MD is you as well, or Kong Mei, Kong MD. You have two logins.
Hi, Professor. Can you hear me?
Okay, yeah.
I'm share my screen.
So you have a two screen. No, you have two logins, right? I think.
I'm so sorry.
Okay.
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 Uh,
So, okay. I can see your.
so in the application defines a problem statement about when we consider window embedding in quantum link, it will have some noise and effect that can may uh, change the structure of the Hamilton. I mean, it can break the chain or it can make a coupling disruption.
So, what is your goal? Your goal is to.
My goal is I will try to optimize the chain length to minimize the error because it affects to the result of the Hamilton process.
Sorry, I don't understand. So, can you speak loudly?
Yeah, I'm consider
And
problem when you know that uh window embedding is a technique that consider one logical qubit. We need to map to the physical device by using the set of physical qubit.
so, what do you mean by this fault tolerant minor embedding?
Yeah, window embedding.
Yeah. So,
But
what do you mean by fault tolerant minor embedding?
yeah,
So, can you explain? I know minor embedding.
yeah,
I know fault tolerant.
yeah.
I don't know fault tolerant minor embedding.
Uh, in many problems that complex, we can just directly embedding the logical qubit to physical qubit. So we need to use a technique is called minor embedding. It means we need to using a set of physical qubit in quantum system to define one logical qubit. It coordinate chain. So if we win, but at that time it will rise some noise and echo. Uh, like if we set the um if the temperature is long, it can uh make an echo like a set of a set of um physical bit. It can represent the one logical qubit. So um, uh, it can rise some noise and echo. Like chain break and coupling disruption.
Okay. Okay, so here problem change. So problem statement is not yet completed, right?
Yeah, I'm just consider some little bit about that.
Okay. So maybe next time you can think about to define the problem. Okay.
Yeah. Okay, understand.
You have any questions, Kong Mai?
No, don't have
No.
any question. Yeah.
Okay. So then move to the next. So in my screen, the next will be Hugh, Tuan Hugh Yung Nguyen.
Yes, Professor, I'm here. Can you hear me, Professor?
Mhm.
Let me share the screen. Let me share my screen.
So Hugh, yeah, right. Yeah, please. Just a sec.
Okay, you have share my report. In this work, I focus on determine the quantum error. Uh, I think it's session 3, Professor. Yes, Professor. And in my case, I mostly wanted to implement about the software noise of the quantum system, and I'm thinking about the decoherence and coherence issue, uh, great noise such as depolarizing issue and measurement without noise. And is this what I add to my report about the definition of the quantum noise, and also provide some related related solution like for decoherence. I thinking about to reduce my circuit depth in my proposed model, and to reduce the operation time, and then reduce the risk to face a decoherent issue. And for read out noise, I'm thinking about to how can I say? I'm thinking about to increasing the number of nodes so that I can I can define the I can reduce the impact of the probability, and in this way, and I focus on zero noise H sharp polite. So I focus on some error mitigation technique in software technique like like zero noise extrapolation, because it's easily to implement in Pennyland library. And in this week, I focus on that and also run some simulation and got the how can I say, promising result in a noisy environment, Professor.
So your problem statement here. So what is the main problem you want to solve?
My main problem I want to solve is that I want to testify about the performance of my hybrid quantum convolutional system in noise environment, because I see several research right now mostly implement the quantum system in noiseless condition. So in the noise condition, I see the reduce of the performance, and then I want to implement my model in a noise environment, and also test some error mitigation technique to reduce the impact of the noise.
Do you have some specific measure for performance, and do you have a specific example where your mitigation technique works good or bad? Can you
Uh,
specify what they are?
Now I already certified zero noise extrapolation, but I don't know. I'm still understand about it clearly to understand about it is a limitation. And I just see the enhanced improved performance of zero noise extrapolation, Professor.
Okay, so it's good that you study the techniques.
Now I think from my result, but I'm not prepared. It's good. It's still lower than noiseless condition, but it can improve significantly the performance of model in noise environment.
So it is good that you study these techniques.
I think it's good. I think it's good
But
and
my comment is you have to specify the problem
yes, Professor.
and clarify what problems you are going to solve,
Yes,
what is the
Professor.
solution. Okay, so
Yes, Professor.
all these are not yet elaborated, and
Yes.
yeah, I suggest you develop the rest. Okay.
This was I will support and add for add
Other
the
que
report. Yes. Yes.
you have questions? Other questions?
No, I don't have any question right now.
Okay, so then the next Lee Byung-ju. Move to
Hi, Professor. Could you hear me?
yeah.
Okay. This week, I defined the topic as machine learning based quantum error mitigation. So I study the background and motivation, focusing on why error mitigation is necessary for current disk devices and how machine learning method can help. So the goal of this project is to develop a machine learning framework or machine learning method models that can learn to correct noisy outputs from quantum circuits. And yeah, so next week I plan to study the quantum error types and review existing paper on mitigation methods, including both conventional and machine learning based approaches. So based on that, I will design the basic structure for my project framework. Okay, thank you.
Okay, so it's good that you define. So I think this is a good example for all of you. So here, the research problem is stated here clearly. So yeah, so this is like the question you make. So I suggest maybe it's a good example. So please define your research problem like in this form. So what is the main question and challenging? Okay, but then my question now to Lee Byung-ju is that this question is a quite broad, I would say. So how can we construct a machine learning model that learns and blah blah blah? So is it a question that has an answer? It's difficult. So it's maybe too broad, or maybe you target. Yeah, I think it would be nice to specify your question. But I think yeah, but it's good start.
You mean more specific problem is needed, right?
So here, if you ask like, how can we construct, then your answer will be, we can construct in this way, blah, 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 blah. Or this is machine learning based on model that provide a solution. So yeah, so if I see the question, then one can expect what would be the outcome, the answer. So yeah, you should pay more attention the relation between answer and questions. So what kind of answers can you expect from this question?
Okay, thank you.
Yeah. And here is also very broad, some machine learning based and so on. Then what is the condition? What is the assumption you impose in the machine learning? So given a data, without data, and these things like this. So it's a bit at the moment it's broad, but it's a good start. I mean, you will elaborate the question and maybe develop further. Okay.
Okay, thank you.
Maybe we move to the next. Kim Dong-min.
Oh, yes, Professor. Actually, I didn't attend the previous classes because I couldn't get the Zoom link through my class email. Actually, I don't know my class email, so I don't know what to do for now. May I know what should I do for this?
Okay, so you're because maybe I don't know. So people from Busan University, Busan National University, how did you get your KAIST email? Because your email should given to you, I think.
I checked my email, but I couldn't get any class email or Busan email in my email box.
No. Maybe here, Doan Hyo. So you are in Busan University, right? And then
No, Professor, I'm in Pukyong National University. Not
yeah, I know you, but you since you're Pukyong University and you don't get the email, but I'm asking to Busan National University students, they got email, right? So for instance, Hugh, do you hear me? Doan Hugh? Or yeah, maybe Tungyang Le Tung.
Hey, Professor, can you hear me?
Yeah, so you have your KAIST email, right?
Yeah, actually, I attend this project from last semester. So my lab they give me the KAIST email, and I just
Okay. So
I just
Kim Dong-min, maybe I suggest you to contact the Graduate School of Quantum Science and Technology,
okay.
the
Professor.
office, and then I suppose they provide you the KAIST account. I mean, otherwise you cannot have access to KLMS. Okay.
Yes, Professor. I will. And I also, after that, I also want to know what should I do to prepare this next week class.
So
Professor.
this is another class that I give a lecture. It's a
Yes.
class that you have to develop your own project.
I see.
So I suggest here, okay, once you have KAIST email, I already sent an invitation to you, I think. Let me check here. Yeah, so this is your email account actually, but you don't have, but there is already email that created for you.
I see.
And you accept and you will accept, and then you come to this overleaf, and then yeah, you create your topic and problem statement and how the problem is concerned with the quantum errors and what you or how to deal with the quantum errors and yeah and develop the project, and that's the whole semester plan. And the evaluation will be made based on your final report on the project.
Yes, Professor. I will prepare for next week. Thank you, Professor.
Okay, so then next we move Im Su-sung. So Im Su-sung is where? Here. Okay, yes.
Can you hear me?
Yes, please.
Yeah. So in this week, in the last week, I listed some terminologies with definitions to answer the first question in problem statement, like 1A, problem statement 1A. Yeah. So
Sorry, okay. How to quantify
Yeah.
the performance of a quantum sensor?
and in 1A it says like why the sensitivity is bounded by Heisenberg limit or standard quantum limit. So to answer it and to write the answer, I studied the definition of the terms that I'm gonna use, and from that I made the statements that I should that I should prove to answer the problem statement. Yeah, that's all.
Okay, so it's quite clear here. So question and answers, and then yeah, so it's significant. It's important what error can happen in this scheme and how you overcome dealing with
Yeah.
quantum errors. Okay. But here's you focus on GKP type error
Yeah.
correction.
Yes.
Yeah, you can choose this is one strategy.
Okay.
But this also has a limitation and as a practical, maybe difficult in practice.
Okay.
Yeah, then you can also think about other possibilities as well.
Okay.
Yeah.
Thank you.
Yeah, because I mean, GKP is not the only solution to this problem. Yeah, so yeah, the solution will depend on how you deal with the errors. Yeah.
Okay.
Okay. Okay. Okay. Yeah. Then move. Chang Hyun-sung is the next one. Oh, sorry. Maybe so. Im Soo-sung, do you have any questions?
No, I don't
At
have
the moment,
something
okay.
else. Yeah. Thank you.
Yes, and then Chang Hyun-sung is the next one.
Okay. In this report, I will compare quantum error mitigation methods. And background and motivation part, I focus on a quantum computing framework based on state preparation, manipulation, and measurement, where computation is performed by evaluating the expectation values of observables. The analysis of quantum error mitigation technique is limited to this approach, in which error primarily affect the accuracy of measured expectation values. And problem statement part, quantum error mitigation is a method for estimating the expectation value of particular observable in a quantum circuit. I think it may not be suitable for circuits where the measurement simply result in 0 or 1 in the absence of error. Therefore, I verify the effectiveness of quantum error mitigation method by using a swap test circuit. This circuit determines the fidelity between two quantum states based on the expectation value of an observable. And quantum error parts, I divided quantum errors into preparation error, gate error, and measurement error. But state preparation and measurement are performed only once at beginning and end of the circuit, whereas quantum gates are applied multiple times. Gate error accumulates and thus account for a higher percentage of the total errors in quantum circuit compared to state preparation and measurement. For this reason, this report focuses on gate errors, assuming that state preparation and measurement error are error-free. And dealing with quantum errors part, until next time, I will like the specific of the quantum error mitigation method. That's all.
Okay. So here, you verify. So okay, this is it sounds a bit unclear. So what you want to do is you verify the effectiveness. Yeah, effective usefulness, or this word is quite difficult to understand.
Okay. I think this usefulness is correct.
So you want to verify so you want to find if this is useful by swap
Yes.
test. Swap test means what? Swap test find fidelity between two quantum states. What are the two quantum state you consider?
I didn't determine yet.
Yeah, then this is unjustified. So you want to find the usefulness of error mitigation by doing something. and find the fidelity between two states, but two states are not defined. Then how can you? Yeah, what do you want to say in here?
Sorry, Professor. I will decide a specific problem and I modify this. Yeah.
Yeah. So what do you want to say? So without this, okay, what do you want to say? So what is your problem then?
I think quantum error mitigation method is not proper to it's not proper for circuits where measurement simply result in 0 or 1 because I think in that case it is better use the majority vote. So I choose the quantum circuit that expected value uh, expecting value in the boundary 0 to 1. Yeah, that's all.
Okay, I don't understand. So please make your problem statement clear next time. And you define quantum errors, and these errors may be solved by your way of dealing with the quantum errors. And then there must be a connections between how to deal with the error and what are the errors. For instance, measurement errors, maybe some of the method is useful, and preparation error, some of the measurement is useful, and so on, so on. So, I mean, the whole structure must be coherent. You define a problem, and then you show how to deal with the errors and what are the errors as well. So at the moment, it's not well connected, and you have to develop the relations between different sections. Okay. Do you have any questions?
No. Fine.
Okay, then Lê Dung Yang, the next one.
Professor, can you listen?
Yeah.
So, in the last, so my focus is just to remind that my main topic is I'm working on design of a parameter quantum circuits to implement some message passing in graph neural network. So in the last week, I just focusing on the motivations and the background of my project, which is I investigate some quantum error corrections and quantum error mitigations algorithms. So first, I look into the quantum error correction code, which is very good for, which is work on like the quantum channel error, and they require some additional qubits to fix the code. So I think this is not very suitable for my parameter quantum circuit. So that is where I'm moving on to the quantum error mitigations, because I saw that this technique does not require additional qubits, right? So, I think my goal in this project is to implement some quantum error mitigations to my quantum circuits. So on the sections 2, I also introduce my system model to evaluate the performance, which is a wireless communication system. And right now, currently, I'm focusing on the section 2C, which is I try to represent my quantum circuits in the mathematically representations. So when
Okay.
so I
Okay.
will compare the noiseless and the noisy representations to figure the impact of the noise to the convergence of the optimization problems.
Okay.
So that is my main goal now.
Okay, very good. Okay, yeah, just keep going. Okay. Do you have any questions?
Currently, I don't have any questions, Professor.
Okay.
Thank you.
Next, yeah. So next, Ho Ji-won.
I update the explanation progress, including concentrating the preliminary part. One of these is that I'll give explicit description of particle loss in sample models and give the explicit computation on.
Okay. Do you have any questions?
No, I don't have any.
Okay. Next one is Jin Chae-young. Sorry. So
do I have to?
I have to move your page. Right. Okay.
So last time I just listed up every possible quantum error model that might be appearing, not based on the specific platform, but every broad scope. But according to your advice, I narrowed it to the superconducting quantum hardware. But and I listed every possible error model that might be appearing in that platform, and also some kind of possible method that can complement it both in hardware aspect and the software aspect. But to describe why those hardware suppression method is possible to suppress those errors, it seems I have to offer some kind of preliminary about the circuit quantum electrodynamics. And I think that might lead my report too broad. So I wonder if it's okay to go through though it will be brief, I wonder if it would be okay to go through the introduction of circuit quantum electrodynamics.
Yeah, I mean, you can redefine your problem again, so that's no problem. But I suggest always you have to be specific about the problem. Okay, and clarify what errors you are considering, and provide how to deal with the quantum errors. So I really suggest you your topic is specific one, and make a I mean, the whole structure must be coherent. So in the end, yeah, it's not like you provide more information by your document. It's more like it's a logical structure. You propose a problem and provide a background and solve the problem. So it's okay. So okay for you to define a problem, and then define another, be more specific and develop the project. It's okay. Yeah. Did I answer you, or did you ask something else? Or?
Just a second, please. What I ultimately want to do is to treat every candidate of the superconducting quantum hardware area of that platform. So I want to treat every possible error, like intrinsic qubit errors, readout measurement control errors, etc. Okay, I'll just narrow my topic again.
And you can include a lot. Yeah, but you can do okay.
Are there any limits of this? How many pages we can write?
No, we don't have any limit. We don't have limit. But in the end, the evaluation is not about the information. It's about how good is your final report as a project development.
Okay.
Okay, I think all done. And any questions? Do you have any questions? Okay, so then if not, I suggest that so maybe in Busan, when is your midterm exam? Is the week of 21st or 14th?
We don't still have plan midterm.
No. I mean, not this one, but you have in your university, you will have exams. Okay. And the others? So maybe Pugyong University, when is your exam period?
Where are we? I'm checking now. It starts from April 22, but
22, okay.
but yeah, I'm okay with every time because I don't have any midterm tests for this semester.
Okay, so then I suggest we meet 28th, okay, the week after exams. So next week, no class, no meeting, 14th and 21st, no meeting. So we meet 28th of April, so almost in a month. And yeah, so you have plenty of time to develop your project, and then we can meet again in a month. And then, yeah, we keep going discussions and how to develop your project. Okay. Is it fine? Oh, okay.
Yes, Professor.
Okay. Yeah. Okay, so yeah, so make quick progress in your project and try to define your project and make a say coherent connections between different sections. Okay. And yeah, so then I will see you 28th. And of course, before that, I mean, I will make this notice in KMS when is the next schedule. Okay. Okay, have a nice day. Okay, bye-bye to everyone. Okay, what? Yes. Yeah, but it's okay. So I yeah, so if I look at your proposals, you have to spend more time on the project. So no exams, only the project itself.
Yeah, Professor.
Other questions? Okay, very good. So I will see you in 28th of April, and in the meantime, you have questions, and just let me know by email. Okay.
Professor.
Okay. Bye bye.
Nice, Professor.